As my professor earlier mentioned, we've discovered that if we use surfactant, which is a chemical, to treat the soil, we can get rid of the problem that the Israeli farmers face, which is the problem of soil water repellency.
Investigations in the greenhouses also seek to verify that these chemicals are safe for the plant in the field.
So, and as you can see behind me here, we have two kind of citrus plants. They are the natives that are grown here in Israel, especially for the rootstock. So, and what you see behind me also is the system. So with this system, we control the irrigation, the water we give to the plants, and also the chemical. So behind me here among these plants, I have 30 of them. So, and 10 of them get just regular water with fertilizer, and 10 of them get the chemical at a more higher frequency every 6 days, while 10 others get the same chemical but every 12 days. So with this system, I'm able to control the amount of water I give to each plant, the rate at which I give the chemical, and not just that, I'm also able to measure at the same time the amount of water that gets exactly to the plant, how much the plant loses through evapotranspiration, how much the weight the plant is gaining with time.
Felix states that, although it may look simple, doing this experiment in the past without the use of this system turned out being very complicated. After 6 months, the results he obtained were inconsistent since the measurements varied with time.
With this system, I can measure for the 30 plants at exactly the same time. And not just that, from my office, I could see exactly what is happening to the plant. I could set when to irrigate, how much to irrigate. I could set the irrigation weather by volume, or also I could set the irrigation weather, irrigate each plant based on the amount of water the plant lost the previous day. So it's really a very fine system. In the soil also, not just the amount of water, I also have like sensors buried in the soil where I can actually also measure the amount of water within each root zone of the plant. So I have like, each pot I have like 2 sensors, one at the bottom and one at the top. So here I see the fluctuation. I know from where the plant is taking up more water. So, and also, if you look closely at the system, you can see like I have the two lines of irrigation, one for the water and one for the chemical, all coming together and going into the plant at the same time. So I could also mix the treatment with the fertilizer all in the same pot at the same time. We've had fantastic results, and because of this result, we're able to modify our experiment. So we could run the same experiment for like 3 months, and then we say, okay, we have this result, let's see what happens if we change this. So because the system is very flexible, it gives me the opportunity to be able to adjust the treatment. Previously, I was irrigating every day. Now we say, okay, since we've seen that every day it's good for the plant, let's see what happens if we don't irrigate every day. I just change that on my system, and automatically this program knows what to do, and the irrigation changes like that. So the whole point of every good research is to have something that the farmers can always use to their own benefit. So this research basically is to help the farmers. We don't just want to tell the farmer, okay, we have a chemical that can solve the problem of soil water repellency, go ahead and use it. No, we want to tell them more than that. We want to tell them, go ahead and use it at this rate because it's profitable, it's economical, and it's safe for your plant. Otherwise, if we just tell the farmer, go ahead and use it, and then they go and they use it, and tomorrow they have a problem with their crop, they run back to us. So we want to solve all the problem using this system before we give a fully error-proof recommendation to the farmers.